Okay, here's a solution to one of the online homework problems from section 2.1. If you haven't seen it, there is also from the MyLabs Plus site, there's a link to solutions to the worksheet from section 2.1 that I go through, and that has several other problems of the same type. But this is problem number 3 from the online homework problems. So if you remember, our process was first we find a formula for the first derivative, so that's 3x squared minus 2x minus 8. And then secondly, we want to set this equal to 0 and and solve for x, and this is going to give us what we call our critical values. In the to factor this, we know that you could just use the quadratic formula, but you should at least give a shot at factoring these things if you remember how to do it, because most of these problems end up having sort of whole numbers or nice factorizations. So when things do factor, usually that gives you a nicer answer more easily. But if you want to just use the quadratic formula, that's fine. So if we think about it, we need to have 3x and x here in order to have this first term. You could have 4 and 2, or 2 and 4, 1 and 8. I mean, there's a lot of different combinations that will give you an 8 here. But I need the sum of the outer and the inner to be negative 2. And so if my outer is negative 6 and my inner is positive 4, then I'll have the outer plus the inner be negative 2. So that's what I'm going to do. So I'll have a negative 6 as my outer and a positive 4 as my inner in FOIL. And so now I have the 3x squared, I have negative 8, positive 4, negative 6x. And so that's going to be the right thing. So that means that my critical values are x equals negative 4/3 or x equals 2. So the third thing we did was draw a number line where we put negative 4/3 and 2 on the number line, and we make ourselves little bins. I think I even drew dots there. These are the critical values, meaning they're the important ones to pay attention to. And so I'm going to fill in my sign chart for, I guess it's not called GF, what is it called, G? So I'm going to fill in a sign chart for G prime of X. I just think it's in each of these, I think of each of these bins out here. And so I know there are, more little points here, 1, 0, negative 1. So I have more little dash lines. But I don't really need to check every one of them, I just need to check something. So for example, I always look for 0. 0 is an easy number to check. It's in this middle bin. So G prime of 0, I can pick it up from this version of G prime, or this is also G prime, right? It's just factored. So whichever one I find easier. Often I think it's easier to plug numbers into these factored things because it's easier to multiply small numbers than it is to square and add a bunch of numbers together. If we put 0 in here, this piece is 4, this piece is negative 2, so that's negative 8, which is negative. And we learned that if it's negative in there, it's going to be negative everywhere in there because there's no other place within the bin where we have these values where the sign might change. So, so number 3 would be a good number out here to check. And again, if you put, so I need G prime of 3, and again, if you put 3 in for x, you get 1 here, and you get, 13 here, but you definitely get a positive number, which is all that really matters. So I'll be positive all the way out there, and then over in this world, negative 2 is going to be the first nice number you come to over in this side. So so I'll check G prime of negative 2, and so again, I just check this. This is negative 4. Negative 2 times 3 is negative 6 plus 4. So negative 2 times negative 4 is positive 8. So G prime of negative 2 is positive 8, which means I'll put a plus here, which means I put pluses everywhere out here. And so finally my conclusion then is that the original function G is increasing on the interval negative infinity to negative 4/3. In other words, all of these places where I have a positive first derivative. And also on the interval 2 to infinity, because I also have pluses out here for G prime. And G is decreasing on the interval -4/3 to 2. So G is decreasing when the derivative is negative. And so what that means is, I can't move that part. All right. I don't know what I can do. I guess I can just go to another slide. So I'll try to remember that part of it. So on this page, I've rewritten the essential information, the original problem, and the sign chart for G prime, and our conclusion about, this is a conclusion about the graph of G. So we can see from this that the graph, if I had to draw a really rough sketch of G of x, so I'll do that first. So I don't really know anything about, just from this work here, I don't really know anything about where the y coordinates are, but I do know that the graph is supposed to first increase for values of x up to -4/3. So if this is -4/3, the graph ought to be going up until it gets there. Then the graph ought to be going down between -4/3 and 2, so it ought to be going down, and then starting at 2 and going up to infinity again, so starting at 2 it starts to go up again. So if this is 2 and this is -4/3 for x, then my graph is going to have roughly that shape. And so if I can picture that, if I can go from seeing the plus, minus, plus information of G prime to increasing and decreasing for G, even if I can only draw a really rough sketch of G, something that increases, then decreases, then increases, that's what this says, increases, decreases, then increases, that tells me where I have these relative extrema. That's definitely going to be a high point, so relative max, and this is definitely a low point, relative min. So you can see that on the sign chart, a relative max is going to occur at a point where the derivative has stopped being positive and started being negative, because the derivatives, the slope being positive to negative means the slope was positive and now is negative, so you now have a turning point on the graph. If you want to know the exact coordinates of this, well, the calculus gives you the x-coordinate, so the relative maximum's x-coordinate is -4/3, the relative min's x-coordinate is 2. So if you want the y-coordinates on this graph, which again, my graph, I didn't even pay attention to it, so I have absolutely no idea about the y-coordinates, I only know about the shape. To get the y-coordinates, I have to go up to this guy and plug in my values of x. So if you put in 2 for x, for example, that'll be easier. So if I put 2 in for x, I'll get 8 minus 4 is 4, minus 16 is -12, minus 1 is -13. So the coordinates of this point right here are x is 2 and y is -13, but I'm getting that value by calculating g of 2. And so similarly, I need to calculate g of -4/3 here, which is harder. I need to go use a calculator. All right, my calculator says that that g of -4/3 is 149/27, which is a hell of a way to write it, but that's about 5.5. So so I know the y-coordinate here, the x-coordinate is -4/3, and the y-coordinate is 149/27, so 5.5 something right there. So the point is I get that from this, and you know, if that's not a bad number, then that's not so hard. Anyway, so those are the relative extrema, but I find them by seeing where my derivative changes from plus to minus or minus to plus. If you want to always be able to work directly from the sign chart, just remember that the derivative changing from plus to minus indicates a relative maximum. The derivative changing from negative to plus indicates a relative minimum on the graph of the original function.